Now, how do we combine functions? Very straightforwardly, we can combine functions pointwise. Meaning, if I want to look at two functions, f of x and g of x, okay? If I want to, then I can define f plus g, f minus g, f times g, f divided by g, simply by saying that at any point x, I add the two, subtract, multiply, and divide. I do have to be careful that I don't divide by 0. Okay, but it's very easy. You could just add this stuff. You have to be a little bit careful about the question of domain, but not really that too much. It shouldn't be too much of a problem. If f of x, domain of, I can't see, all right, domain of f of x is A, I'll write it properly, and domain of g of x is B, then domain of all of these combinations is the intersection of A and B, meaning all these have to be defined and all those have to be defined. So if it's so you just look at the whole thing as a whole and you can say where it's not defined. And for this one, of course, you also have to throw out the points from the domain of G where G of x is 0. So G of x not 0 in f over G. But if you have a question like that and they ask you to look at the domain, you can just look at the domain of the final thing. It's fine. It's not hard. So there's nothing really tricky there. More interesting is composition of functions, right? We do a lot with composition of functions in calculus. So it's important to understand what composition of functions is. You'll see two different notations. So I've got two functions, f of x and g of x, right? The composition, and you see it written sometimes as f circle g of x. It just means you stick the second function in the first. So the way it's written f circle g, it's f of g of x. So if I write g circle f of x, it's g of f of x. Okay? So basically, you're sticking one function into another function. All right, so I know you've seen that before. It's not like something completely new, but we do a lot with this with calculus, with derivatives, with chain rules, so you have to be pretty well versed in like looking at a function and seeing it as a composition of functions, that sort of thing. So one thing I wanted to basically briefly mention was the domain. You do have to be careful with the domain of composition of functions. If they give you two functions, it's more than just looking at the end, the domain of the end part. You have to make sure that this actual thing is defined. So whatever is in the range of your g of x has to be in the domain of your f of x, right? So it actually has to be defined all the way through. I'm not going to make a big deal out of that. You're not really going to see that in this course. Like, I don't know, there might be a question on website on that, but I'm not even sure it is. But there can be, and maybe later on in your life, math life, you'll be in a situation where this is important, but it's not really important for quite some time. It's just a question of defining, because when you define this operation, you're taking sets, you're taking a mapping from one set to another set to another set, so it just has to make sense. So that's all that talk is about. In practical terms, we won't really ever see that. In practical terms, what I want you to know how to do is just how to use this notation and how to compose functions. So, for example, we have one here. F of x is x over 2x plus 1, and g of x is 4x minus 2. Let's make it a 3, so we can track everything. Okay? So if I do f circle, let's try over here, f circle g, that means f of g of x. It means I stick g of x in for every x here. So I stick this whole expression in for each of these x's. Okay? So the top is 4x minus 3. The bottom is this. And if I like, I can clean it up a little bit. So I don't have to look at this. What is this? 8? 8x minus 5. Okay? So I have a new function. Okay? If I do g circle f, g of f of x, okay? What I'm going to do is stick an f of x in for every x in g. Well, there's only the one, right? So I need to stick in this whole expression in there. Okay, so am I done? You can be done. I don't care. You can make a okay, so that's another question. Just for kicks, we should discuss this. How done is done. It's nice to have a final answer. You make a nice common denominator. It's pretty. If you don't, am I really going to care? Probably not that much, huh? If it's a complete mess, I can't figure out what it is, then maybe I might care. So just a reasonable answer is nice to have. Especially also, by the way, for WebAssign, sometimes it'll be something really long and gross, but if you just do a little bit of extra calculation, it becomes something nice and small, and then it is much faster to type into the computer. Right? So that's also for your purposes, how much do I have to simplify? One other thing, we can do this, and we will see this with multiple kinds of functions, right? So, and you don't have to have just 2, right? You can do f of g of h of k of x, right? Like you could have a whole bunch of nested functions, okay? And in fact, that's what we'll see quite often in this course. If you have something like, I don't want to square it, I don't know what it is. So, sine of 3x plus 4 squared to the, let's put a square root out there, sure. Okay, like that's not even that bad, right? That's like almost nothing. But you see there's a couple of different functions here. That could, is that 4? I don't know. So the most inside one is this, right? So I'll call that k of x is 3x plus 4. Now I've got a square on that, so maybe that's my h. Then I've got a sine, so that is my g. Oh, I do have 4, see? And my most outside function is the square root, so that would be this. So I could give you this and ask you to write down this, which is in fact f of g of h of k. Or I could, what you'll really see that we do in Calculot, I get some nasty mess like this, and I sort of have to understand how to break it down like this, because we're going to need to be able to do that to use some of our rules.